friction. So what is the wedge? So wedges, which are small pieces of material with two of their opposite surfaces not parallel, are employed to elevate heavy objects like blocks, machinery, precast beams, etc. in order to facilitate the insertion of lifting devices and achieve precise alignment. It's important to note that the weight of the wedge is negligible compared to the load it lifts. So in all practical application, the weight of the wedge is disregarded, means not considered in the design. We can see here the figure of wedge. Now we will directly move towards the numerical. Determine the minimum force required to move the wedge shown in figure. The angle of friction for all contact surfaces is 15 degree. Figure is given here. One 40 kilonewton block is lifted with the help of wedge, and one force is applied to the wedge, and its angle with the horizontal of one of the edge of wedge is 20 degree. And determine the minimum. If we see the statement of the numerical, determine the minimum force required to move the wedge. So we want to find here the P value. So we will solve here the step by step. So solution. So first step is to solve or to analyze the wedge problem. Draw separately free body diagram of each component like block or wedges. So first here we consider the wedge and draw the free body diagram, or what are the forces acting on that. So draw here the first block. It's having the weight W 40 kilonewton, which is acting downward side, and draw the line of action of force. Then from the wedge side there is a normally will be there, or we can also call it as a resultant. Then it is denoted by R2, and having the angle is what is the 20 degree, and in the numerical is given for all contact surfaces. All contact surfaces is 15 degree. So also take this angle in the calculation is 20 plus 15, that is 35 degree. So this is R2 in between the block and the wedge surface resultant. Then from the wall side or wall surface there is another resultant will be there. There is a R1, and having the angle is what 15 degree. So whenever there is an angle is given to the wedge with or block, it is considered as first this angle, like here is given 20 degree, and for all contact surfaces angle is add in that angle. So draw the force diagram for this. Is load or weight of the block acting downward side, which is 40 kilonewton. Then R1 is, take the force line of action is here is R2 and R1. R2 is acting upward side, and angle is 35 degree. Similarly for the R1 its angle is 15 degree with the horizontal. So this is the force diagram for the block. Similarly for the wedge angle with the horizontal is 20 degree. So equal and opposite in between the two surfaces, the block and wedge, is one reaction will be there or resultant is R2, equal and opposite. And from the right side there is a apply the P force, which is we have to calculate here. So R2 is having the equal and opposite, means what? Is angle is same, that is 20 plus 15, 35 degree. And from the ground side, one reaction or resultant will be there is the if force is acting left side direction, then reaction is from the right side, for the right side direction, and angle is 15 degree, and we denote as the R3. So draw the force diagram for this. Is R2 acting left side, downward side, P force acting left side, and R3 acting upward side. So one by one we draw here the force diagram. So R3 acting upward and angle is 15 degree, P force acting left side, and R2 which is acting downward side, and angle is 35 degree. So these are the separate free body diagram for block and the wedge. For force diagram also mentioned here. So solution. First we consider the block, force diagram, and apply the Lami's theorem. When we apply the Lami's theorem, when three concurrent forces acting outward side, outward side, then we can apply the Lami's theorem. Three concurrent forces which is acting outward side, then we can apply the Lami's theorem. So apply the Lami's theorem to this system. For block, R2 divided by angle between this R1 and 40 kilonewton force, then R1 angle between the 40 and R2, and similarly for the 40 kilonewton, that is angle between the R2 and R1. So this is the formula for the Lami's theorem. R1 divided by angle between the R2 and 40 kilonewton, that is sine 145, is equals to R2 sine 75 degree angle between the 40 and R1, is equals to 40 divided by angle between the R2 and R1. So just equate the first and last term and simplify it. Just do the cross multiplication and divide by sine 145. Then R1 will be 35.694 kilonewton. Similarly for the R2, equate the second term and last term, and then after simplifying, R2 will be 60.108 kilonewton. Similarly for the wedge, force diagram for this is in front of us, and also apply the Lami's theorem for the wedge. So P upon angle between the R2 and R3, that is 130, is equals to R2 divided by angle between the P and R3, that is 105. So we are interested only to calculate the P value, determine the P force. So simplify it. R2 we have the already calculated the value, that is 60.108. just put the value, simplify it, and we'll get the P is equals to 47.67 kilonewton. So in this way we can solve any problem of wedge